So let's end this by doing one last exercise, and then we can give you guys a few challenges. So let's just say simple calculate. Create a function that takes in two numbers and a mathematical operation. And performs the operation on the numbers. It's simple as that. So we'll call it function. I'm going back to JavaScript. We'll call it def and it takes in two numbers, so we can say A, B, and then we can say operation. So once again, as many parameters as you want, although parameters are variables. These are variables that we're creating. Then we can use them, and we can use them inside here the way we'd use any normal variable. Anyway, you can have as many parameters as you want, separated by commas. Great. So one last statement to add. And returns the result. Very well. So def calculate A, B operation. Now if it was always going to be addition, we could simply just write A and B and leave it at that. In fact, return we run that, and then we say we just say calculate 1, 2 and 5. Oh, sorry, I forgot this. Let's just put that for now, and we can print it. So print calculate 2, 5 and its addition, and then it gives us 7. So that's good, but that doesn't work because if we do multiplication, nothing happens, or rather it still just adds. If we do division, it still just does that. So first we have to check what the operation is, right? There's only 4 possible options, so we say if operation is equal to addition to that, then we can return. I can just tag that in, and that's fine. So now we run this, and if we run this now, we get none because we haven't dealt with that. If we put minus, we get none still. But finally, if we put plus, we get 7. So now all you have to do is the same if statement for the different ones. So addition, multiplication, subtraction, and division. And then equally, we multiply, we minus, and we divide. So that still works. Let's try multiplication. That works. 2 and 5 multiplied is 10. Minus, -3, good. Finally, division, 0.4. Excellent. So that works perfectly. We could even put an else, because somebody will come here and write minus and then get none, but then they'll wonder why they've put a correct mathematical operation and they're getting none. So we could put return wrong operation. Now we do that, and now we get wrong operation. But if we do this, we get our -3. Yeah, let's change the numbers just because we can. 10 and 9 and 13. -4 multiply 117 divide is that long number, add is that, right? But if you put something weird like that, it says wrong operation, right? Now you could extend this. You could extend this further, because somebody will come in here and they'll put 9, and it is giving the error message, which is good, but it's not that they've put in a wrong. Oh look, let's do that. Good, exactly. Okay, it wouldn't even work at all because it's saying unsupported operand types, string and int. We tried to we tried to do a mathematical operation with a number and letters, a string and a number, so that doesn't work. All right, so you could extend this, you could make it better, and that could be a fast challenge. Use what you've learned so far to do some validation on whether this and this are actually numbers. Okay, so that was a simple exercise, and now we can give a few challenges, but I'd like to do that in the actual class when we meet. So please do your own research, play around with this, make some functions, and yeah, we can see what we will learn in the next class. Before I go though, something worth noting. You will notice, let's put this back as 9. So we get our -4, right? Which means we got all the way to here. Whenever your function hits a return statement, doesn't matter what else follows, it will stop there. It will run whatever code exists at that line. For example, it will return 9 minus 13, in this case a minus b, and then it will stop operating, and it will give control back to where it was called. Something worth keeping in mind. Okay, I'm going to stop there. We can discuss more in class. Thank you very much for joining this session. I hope to see you when we meet in the actual class. Hello everyone. Welcome to today's class. Today it will be a virtual class, but we will still have our usual discussion afterwards. So, today we're learning about functions. A function is a block of code that runs when it is called. So, as always, we will just start with the syntax before we do any explanation. So, to create a function, you start by writing def. You write the function name. You put brackets. Always, it's part of the rules, even though they're empty, and we'll explain that in just a moment. And then, as you're used to by now, you put your colon, and with an indent on the next line you can put your actions, as many as you want, as many statements as you want. So very quickly, an example: def greet brackets colon, and on the next line, indented, we can simply write print run that, and notice nothing happens yet. So we've written this function and nothing has happened, because remember the second part of the definition, it will run when it is called. So on another line I can write greet, put the brackets, and this time it says hello world, and I can do this as many times as I want, and I do it 3 times, it runs it 3 times. So functions are used whenever you have a process, a set of actions that you will do often in whatever program you're doing. Instead of writing the code over and over again, you can make a function and instead call that function, and it'll run that set of code. So in this case, instead of greeting our users saying hello world when they come to our system over and over again by writing print hello world, we can simply put it in a function called greet, and whenever we run the greet method, whenever we write greet, we will get that functionality happening, that hello world. So let's add a note here. I might interchange between these two words as we go along the lesson, but just know that they are the same. Functions and methods are the same. I come from a Java background, so I am used to using the word method, but functions, if you hear the word functions or methods whenever you're doing your research, just know that they're talking about the exact same thing. Now, in our classes, we've already looked at quite a number of functions, pre-built functions that belong in Python. Let's take a look. For example, we did a lesson about string, and I told you to go look for string methods, so I used that word in that case. And whichever we look at, all of these words that end in brackets, these are all functions, right? Or methods, depending on what documentation you're reading. So for example, capitalize converts the first character to uppercase. The people who helped create Python, they made the capitalize method, and now instead of us writing the code that will capitalize the first letter of a word over and over again, we just have to call capitalize and we get that functionality. So all that we are learning in this class is how to do that exact same thing, but now for ourselves, for things that we are trying to build. Alright, so that's the simple syntax, greet. We can make another. So I've made my function, and when I run the cell, nothing happens. But if I call the function, we get 6, because those are the numbers I put there, 2 and 4. So if I put 3 and 6, run that, and then run my function call again. This time I get 9. 3 plus 6 is 9, right? But of course, both this and this are very simplistic examples, and they are static, meaning this will always just say hello world, this will always just add 3 and 6, which isn't very useful. So let's see if we can extend this topic a little bit. Let's learn about arguments. Or rather, I should say parameters stroke arguments. Once again, you'll come across both terms, so I'll show you when both apply. Information passed to functions. Simple as that. Arguments are simply information passed to functions. They're used to augment the functionality of a method that you create. Yeah, they're used to make it more useful. Yeah, if you can put it a bit simply. So create a function that adds 2 numbers. We've already done exactly that, but now we want to do it such that the user can decide what numbers. So we can simply do this. Once again, you start with def, you give it the name, add nums, so we'll just call it that so that it's different. The rules of variable names apply also with function names, and one of those rules, as you remember from our class, was they cannot share names. Alright, so put our brackets, and then inside of the brackets we can say a comma b, and those are our arguments. So then we say print a plus b, simple as that. We'll run it, nothing will happen. Let's make a new cell, so then we can say add nums 1 and 2, and that gives us 3. 1 and 4, that gives us 5. Right? So that's how arguments work. Create a function create a function that greets a user. So def welcome, and then we put the function, the parameter of name, and then the next line we can say print welcome plus name. We run that, and in the next cell we can actually use it. So we can say welcome, and we can put that, and it will say welcome email. Right, so two functions, and they both have arguments now. So now I can tell you the difference between parameters and arguments. When you create the function, these are parameters. When you're actually using the function, when you call it, these are now arguments. So that's just worth knowing for the sake of, if you're doing your own research and you see both being used, at least you will know where they apply. Also, I'm deliberately putting the function in a separate cell as the usage, because I'm trying to stress the point. It's not enough to create the function. It won't do anything on its own. You actually have to call it. You have to write its name, put the brackets, put any parameters if they're needed, then you'll actually get that functionality. Something else worth noting, if you don't put the parameters, it crashes. Welcome, missing one required positional argument. If you have to put the arguments if they are specified. Okay, you can have as many arguments as you want, you just separate it with a comma. Okay, good. So that's arguments, that's parameters stroke arguments. That's how that works. Now we can do a few examples. I'll put this back. There we go. Let's create a function that will ask the user for their age, their current age, and will print their year of birth. So first we write def. Let's just call it YOB, meaning year of birth. First thing we want is the year the person was born, so we can say, sorry, the age of the person, so we can say age is equals to input when were you, sorry, how old are you? Simple as that. It's always good to test as you go, so I'm going to run this cell and then immediately just type your birth, and it'll ask how old are you, and I can put in my number. Good. Alright, next thing we're doing is we are doing that calculation. So year of birth is equals to current year minus age. So if a person is 10 years old, that means they were born in 2012. How do we know that? Because the current year is 2022 minus 10, that's 12, right? So that means we can use this as our parameter. We can take this and we can put that there. Def year YOB, and then it takes in the current year. It asks for the age, and it simply calculates the year of birth is equals to the current year, which it got from the parameter, minus the age, which it got from this input. And then we can simply print that. We run that, and then we come here. If we run it now, it will give an error. It needs the current year, which means we can put it at any year we want. So let's start with just 2022. We run that. How old are you? Let's say that, and we get an error. Let's read it. Unsupported operand times for int and string on line 3. So what did I try to do on line 3, which is this one as it's indicated? Year of birth is equals to current year, which was 2022, minus age, which was 27. But the problem here is that any input is considered to be a string, so we have to cast it. So we can say age is equals to int age. So now we've casted it to a string. We can run this cell again, and now when we run this, how old are you? 30, and it says you're born in 1992. Alright, just a note, you don't have to cast it like this, you don't have to do a whole other line, you can simply do a one-liner like so. Run that once more, run this again. How old are you? 12, you're born in 2010, and that is as simple as that. Okay, so that's how you create functions. Let's learn one more concept, and that's about the return statement. The return statement allows functions to give back information. Let's do a very quick example. So def hi, return hi. I'm going to run this, and now let's, in another cell, let's use it. So I run it, I call it, and I run that cell. Oops, I'm in the wrong cell. This is the cell I want to run, and it just gives me this hi as a string, right? But what's actually going on? When we use return, it allows the function to give back wherever it was called, it can give back information. Now technically, and this is getting a bit into the computer science, but technically the return on its own means give back control So in your code, you'll have, rather in your program, you'll have lines of code, right? You'll have lines of code all the way above, and then eventually you'll call this function. Within the function, you'll have a bunch of lines of code. As soon as you hit return, regardless of what you've written after it, essentially this means give back control to wherever you called the function. All right? Now, why is that important? Well, for our definition, it really isn't. For our definition, it does. The computer science definition isn't that key, but it's worth knowing. What is important, however, is that when you give back that control, you can take data with you. All right. So let's do an example that has more meaning. Create a function that multiplies two numbers and returns, this time does not print. So far we've just been printing directly inside the function that returns the product. Okay, so this is very simple. Def multiply A and B, return A multiplied by B. Alright, we can run that cell, and then in the next cell we can say print multiply two and 4. What does that give? It gives 8, right? So essentially you'll notice we write the print ourselves, but then inside the brackets we call the function. Okay, now here's a simple way. Here's how I like to think of the return statement. This helps to understand the concept. The return statement, there's no need to run that, but there we go, I've run it. the return statement makes the function act like a variable. Alright, so here, let's put a line above. We could have said just a random number is equals to 8, and then we could say print that number, and when we run this we get 8, right? So print takes in whatever you want to print. It can take in direct digits, of course, direct values. It can take in variables, right? But now I'm showing that it can also take in functions that have used the return statement. Why? Because the return statement is giving back data, and therefore it's acting like a variable. This multiply 2 and 4 is acting like this num is equals to 8, or even we could say num is equals to 2 times 4, right? And they both give back 8. It's as if this multiply 2 and 4 was a variable that's holding the 8, right? And of course if it was anything else, same thing, 5 and 10, 50, right? So multiply 5 and 10 is carrying. Remember, a variable is just a container of data. Multiply 5 and 10 is containing 50, yeah? But that's not the technical definition. You won't find that in a textbook. That's just how you can, a way to help you think about it.